Here's the graph for the absolute value of y equals 2x minus 6. So we can see here the graph in blue is the graph of y equals 2x minus 6. The graph in red is when we graph the absolute value. So everything that was below the x-axis in this region has been flipped and reflected to be in the positive region of the graph. So to figure out the domain here, I know that my graph is expanding in the negative x direction. It's also expanding in the positive x direction. So that means that our domain is going to be x, e, r. X is an element of all real numbers. Our range for the graph of the absolute value, nothing's going below this point. Nothing's going below our x-intercept. The x-intercept is really important with absolute value graphs. We call it the invariant point. This is where our graph basically turns around so that nothing goes into the negative y values here. So our range is y greater than or equal to 0. Nothing's below this point for our graph in red. Piecewise, now this basically means that you're going to be describing your graph in both the positive and the negative, because we know that with absolute values, this 2x minus 6 can either be positive 2x minus 6 or negative 2x minus 6. So 2x minus 6 is positive if x is greater than 3. So here at our x-intercept, this is where the positive portion of the graph begins. So everything greater than that is the positive region. So we say if x is greater than or equal to 3. Now this section here, so where we originally had it in blue and where it was reflected, everything that is below x equals 3 is the negative case. So our absolute value, this whole thing, 2x minus 6, is negative if x is less than 3. Now the equal to 3 is included with the positive portion, so we just say less than 3 for the negative. And this is what we mean by piecewise. So it's just the positive case and the negative case.